Avogadro's law is pretty straightforward. If you keep the pressure and the temperature constant for a gas, then the only way that you're going to actually expand the volume is to actually put more moles of gas in. And so therefore, at constant temperature and pressure, the volume of a gas and the number of moles of that gas are directly proportional. So V1 over N1 equals V2 over N2. And that's Avogadro's formula. Don't use it too much because it's kind of obvious. But anyway, if you were to graph that, well, if you had zero number of moles, you'd have zero volume. So you can start down there at the 0 mark, and you work up in a directly proportional manner. Here's the thing. Avogadro came up with 6.02 times 10 to the 23 because all gases at pretty much room temperatures and pressures can be treated ideally. That means pretty much the same as each other. So there's an ideal gas law that can be formed from Charles' law and Boyle's law and Avogadro's law all combined. You don't even have to memorize the other formulas, though you should know those graphs. Those other three formulas, get them out of your head, because you can use only this one to derive all the others and then some. PV equals nRT, PUVnert, that's what it's called. And PUVnert, where R is a universal gas constant, will actually be able to solve all of your mathematical needs in the gas unit. Now, 8.314 is that collected constant K for all of those other formulas together, and we call that R now. 8.314 kilopascals times liters divided by kelvins divided by moles. So, kPals per kmol. If you memorize this number, or just have it handy all the time, 8.314 kilopascal liters per Kelvin mole, you can solve problems like this. Okay, watch this. You have 30 milliliters of a gas at 200 K and 150 kPa. And you're going to warm it to 300 K. The temperature is going to go up and the volume goes up to 40 mils. But what's the new pressure? Now, that's not a Boyle's law question or a Charles' law question. It's kind of combining both of them. So what do you use to figure out the answer? PUVnert. You use PUVnert. That's all you need. PUVnert. But here's the thing. You're going from an initial pressure and volume and temperature to a final pressure, volume, and temperature. So how do you use this formula? Watch the manipulation of this formula. PV equals nRT. Okay. If I take every one of the variables that undergoes a change in this question and isolate them on one side, then the other side must equal a constant number when multiplied together. Watch. P and V change in this question, and so does T. Temperature changes too. So if we divide each side by T, here's what we get. PV over T equals nR. These all change. These stay the same. If those two numbers stay the same in this question from the initial to the final state, then these are a constant K. And remember, if these are a constant K, then here's what happens. If you change this from an initial condition to P2 V2 over T2, you get a final condition. And ladies and gentlemen, that means then that PUVnert just gave you P1 V1 over T1 equals P2 V2 over T2. Some people memorize that formula and call it the combined gas law. I don't memorize anything except PUVnert. Now let's plug in the numbers. Here's your combined gas law formula. There it is right there. P1 V1 over T1 equals P2 V2 over T2. You know, we're solving for P2 here, the new pressure. So we have to divide each side by V2 to get rid of the V2s. And we have to multiply each side by T2 to get rid of the T2s. So you see, that's how you do that formula manipulation in order to solve for P2. So P2 equals P1 V1 T2 over V2 T1. Okay, that's a lot of stuff to actually put in. Now, a lot of people will write down all of the numbers in the question down the side and then plug them in. That's fine, you do that. So P1 is your 150 kPa, your volume 1 is 30 milliliters, your temperature 2 was 300 K, your volume 2 was the 40 mils, and your temperature 1 was 200 K right there. You do that math right there, plug everything in, where your milliliters cancels mils and your kelvins cancels kelvins, and you're left with kPAs. And the answer, it's going to be to 2 significant digits. So when you punch all this and you get about 168 kPa, can't say that as your answer, can you? You have to say 1.7 times 10 squared, because that's 2 significant digits, kilopascals. Look, if you can do that one, you can do all of them that involve Puvner. And just in case it ever gets mentioned to you, Dalton's law of partial pressures can actually be a very important concept to understand in doing certain calculations. And all you have to know about that is this. That Dalton found out that if you have a gas here and it has a certain pressure, and then you add a certain pressure of another gas into the container, what's the total pressure now of the system? Well, the partial pressures of the individual gases together, added together, equal the total pressure. So if you have it inside of a container, 10 kPa of oxygen and 10 kPa of hydrogen gas, well, what's the total amount of pressure in that container? 10 plus 10 equals a total of 20 kPa. That's all you have to do. You add together all the different partial pressures to get the total pressure inside of a container.